Alright, I'm gonna be in bed for a while, doctor's orders, but I didn't plan on doing this till later this year, but a little hard to see because it's not turned on. This is the modified version of our magnetometer. It's a full Arduino with a TFT LCD shield. This does have a touchscreen, which I may use some of the touchscreen functions later. I'm not sure what for. Maybe to toggle between a compass. I don't know, but I'm going to plug it in. It does a self-test after a nice little splash screen, and it's plotting and giving a correct heading. I'll try to keep the camera as still as possible. Now to go through a self video test, RGB. And down at the bottom in red, in case you can't read it, that's your x-axis value. Green is your y-axis. Still have to align the text a little bit. Blue is your z-axis, and white is your heading in degrees. 360 would be magnetic north, and so it's plotting X, Y, and Z. I'm not going to plot the heading just because of this amount of screen size that I have, but as a disturbed sensor, if I had a magnet nearby, I would approach the magnet, approach each axis with the magnet, and you would see just that axis change. But here's the sensor, made by Honeywell. So I don't know if you can see the degrees or not, but there is almost magnetic north. Yeah, but I still have to align the numerical data at the bottom. I've got to shift that over a little bit. And it's plotting strength in units of milligauss. Simple conversion to microtesla is just move one decimal place to the left. So like, for instance, 147 milligauss would be 14.7 microtesla. So you're just moving the decimal point one place. But that's where we're at right now. Still working on the desktop version. Everything's working fine over USB serial. In the middle of implementing Bluetooth so that the device can be put on external power and in a remote location. And should have that out sometime soon.